let's do a question. The question is, find the dimension of Planck's constant, which is represented by h, small h. So we have E equals to hf, which is a formula. Not that necessary to know where it comes because we will learn about it in a future video, but just know that there is a formula that has E equals to hf, where E is the energy, F is the frequency, and h is the Planck's constant. So h can be written as E by F. So here, so let's just write it, where E is energy and F is frequency and h is Planck's constant. So now in this equation, h equals to E by F, we have here the dimension of E is actually, it is of same of that of energy, because E is energy, which will be ml squared t minus 2, and similarly the dimension of F, which is frequency, will be t minus 1, because the most common formula of frequency is 1 over time period. So now since the relation is physically correct, it means that it must be dimensionally correct. So we can write the dimension of h must be equals to the dimension of E by F. So let's put a pretty bracket around it. It's supposed to be a square bracket, but don't mind the round brackets. So now here h, the dimension of E will be ml squared t minus 2 divided by the dimension of F, which is t minus 1. So when dividing both of them, it's pretty clear to see what you will get as a result. So we can say the dimensional formula of h, which is a constant, is actually m to the power 1 l square t to the power minus 1, because minus 2 divided by minus 1 leads t to the power minus 2 divided by t to the power minus 1 leads to t to the power minus 1, basic rule of indices. So now this is the dimensional formula of Planck's constant. And since the video is quite short, let me just add a little bit of detail. So the value of Planck's constant is actually, so it's approximately, not exactly, approximately it's 6.62 into 10 to the power minus 34. Now what about the units, you might be saying? So energy is measured in joules and frequency is measured in hertz, which is 1 over second. So second goes up, it will be joule per second. And I will add further information in the next page. Why not? Because we have some extra time. So over here, when doing this, what happens is minus 2 minus minus 1. That's why it will be t minus 1. So look, minus 2 of the top, minus 1 of the bottom. When it is on divide, due to laws of indices, there will be a minus, which gives us minus 1. So now let's just give some notes, since there is a lot of time. So h is approximately 6.62 into 10 to the power minus 34 joules per second, and this is called the Planck's constant. And also the unit of energy, the unit of energy is actually joule, or just written as small j, capital J, and the unit of frequency is hertz, HERTZ, or you can write it as SZ. It is actually, so let's just write a joule. Joule is actually and hertz is actually. The most common formula of joule the most common formula of work done or energy will be F into D, which is force into displacement. So force is kilogram meter per second squared. Multiplying it by another meter, we will get kilogram meter squared per second squared. And hertz is 1 over time period. Time period has a unit of second, so 1 over second will give us per second. So this was a few notes, because I don't want to end it by a short video. Let's make it a long one, why not? And so this was it for today's video. In the next video we are also gonna do another question, which is also related to finding the dimensions of constant in a relation.